following is a presentation given at the Thai Texas Funding Forum 2015 in January. The partners are TEN and the Business Makers Show, sponsored by Baker Hughes Incorporated. And this presentation is by Big Delta Systems.
Thank you everyone. Thank you all. Good afternoon. I'm Charu Galande, co-founder and CEO of Big Delta Systems. Now, our story actually starts way back in 1849, the California Gold Rush. And that was a time when the rewards were massive, and little time was spent in rational thinking as thousands flocked to California to make it big. But in the end, most walked away disappointed and empty-handed. Now, fast forward 150 years. We're now in the midst of a new gold rush, except this time, the new gold will power every aspect of our lives, from smartphones to cars. This time, the goal is the lithium-ion battery. Again, the rewards were massive. So many companies charged ahead, and investors poured in millions of dollars behind claims of big breakthroughs in battery chemistry. But yet again, many walked away empty-handed. The good news is that the price is still there. And so this gold rush has continued, with companies continuing to focus on developing new chemistries. But the fact of the matter is, where we are today in terms of cost and performance versus where we are projected to be versus where we need to be is more than just a little short. And this gap cannot be bridged with new chemistries alone. At Big Data Systems, we have rethought the approach to attacking this problem. Instead of focusing on what batteries are made of, we have reinvented how batteries are designed and manufactured to make them better and cheaper with any chemistry. And now to understand exactly how this works, let's take a look at what's inside a battery. A battery is actually just like a sandwich with lettuce and bread. The bread slices, like the electrodes, are the sources of energy, and the lettuce is the inactive material which does not store energy. Now, if I were to make my bread slices really thick, I will eat more bread and less lettuce, and so I'll get more energy. On the downside, however, I won't be able to eat this sandwich very fast. Something very similar happens with batteries. A battery with thick electrodes can store more energy, but can be charged and discharged very fast. Well, we have unlocked the key to this problem. So while most companies are changing what electrodes are made of, we have reinvented how they are designed. We have patented a new ultra-thick electrode structures that allow batteries to store more energy and still charge and discharge really fast. And this directly results in a 15% increase in energy density and a 12% reduction in cost. And this is equivalent to a 5-year boost in the industry. And the best thing is, our approach will amplify improvements from any future advances in chemistry. Now, in order to make these advanced electrodes, we actually invented and patented a versatile spray-based manufacturing process. And our innovative approach gained wide recognition when we first published it in 2012. Now, we fully realize that changing an established manufacturing process is capital intensive. So our business case fundamentally depends on our technology creating more value than the adoption costs of a new coding process. So with this in mind, we reached out extensively to battery manufacturers, tool developers, national labs, and end customers across multiple industries, ranging from aerospace and defense to electric vehicles, to talk about our technology. We learned that our solution is widely applicable for batteries in multiple markets, and that our technical approach is both realistic and valuable. This means that our total addressable market is a combined $43 billion in 2020. Out of this, we will first target the $300 million aerospace and defense market as our beachhead market because of early adoption, a desperate need for high energy density, and low sensitivity to the price point. So we will begin here and eventually move towards higher value applications that have longer adoption timelines. So how are we going to commercialize this technology? Well, we've learned from the past failures in the industry, and we are not going to do this alone. So we have developed a unique triangular business model of joint development partnerships with cell manufacturers and tool developers to commercialize this technology in the most capital efficient manner. This allows us to focus on our core competency of electrode design and manufacturing innovations while leveraging the resources, expertise, and market presence of our partners. And since we have key IP on cell designs as well as manufacturing methods, we will generate licensing revenue from both battery manufacturing and capital equipment sales. Now, in an effort to complete this triangle, we've talked to more than 20 key industry players across the value chain in multiple markets, and we have received great response. In fact, we have 6 MOUs and 3 letters of interest either signed or in progress with potential partners. So what is the focus of these collaborations? Well, first, we've defined technical milestones for initial validation in the next 8 months. Second, we will then share and validate our technical data with our partners. And third, based on the validation results, we will convert these collaborations into joint development agreements that will help us fund further validation and scale up. So today we are seeking $1.25 million in seed capital to fund these industry-validated technical milestones over the next 18 months. Reaching these milestones and converting our relationships to JDAs will create significant value for the company, setting the stage for an accretive Series A near the end of 2016. After that, we will work with our partners to build roll-to-roll equipment prototypes and subsequently a pilot coding line before reaching production scale. And our discussions with our industry partners indicate that this entire process will take approximately 4 years. With this timeline, we will enter the aerospace and defense market after year 4, the consumer electronics market after year 5, and subsequently the EV market after year 6. So how does this look financially? Well, with funding expected from JDAs with our partners, we expect to be cash flow positive after year 4. And after market entry in year 5, we will break even in year 7. But with a customer-driven milestones and commercialization strategy, we expect to create exit opportunities for our investors beginning year 5. Our exit will most likely be through an acquisition by a battery company or a major process tool company, and we expect to provide a 63% IRR and a 10x cash and cash to our earliest investors. So where are we now? Well, we started in the June of 2014, completed the Outspark Startup Accelerator in August, raised our first angel investment in September, and won an innovation prize in October. And today we are seeking seed capital to fund our development milestones. We're also seeking federal and state grants that are aligned well with our technical and commercial goals. We've already built a bench scale manufacturing equipment prototype that is capable of making large area electrodes and full cell battery prototypes that can power even smartphones. All our intellectual property has been invented by our co-founders. 3 of our patents are owned by Rice University, and we have a 1-year exclusive option to license them. We have also filed 2 additional provisional patents owned by the company. Now, as an innovation-focused company, we will continue to file new IP targeting critical needs of the industry. In fact, our manufacturing innovations give us tremendous future possibilities, such as making flexible batteries, like this battery we've built into a watch strap, or even batteries directly integrated with surfaces, like batteries integrated with ceramic walls or even UAVs. And finally, we have an incredibly talented and passionate team. Neelam is our CTO and the principal inventor of all our magic. Adrian is a brilliant engineer and a certified wizard, and he keeps our magic going. Shadir is a Rice MBA, and he brings valuable business acumen and plays the devil's advocate in a room full of scientists and engineers. We also have a fantastic set of advisors. John Riale, our business advisor, Professor Ajay, my PhD advisor, and Dr. Robert Miller, a friend and battery entrepreneur, all bring valuable business and technical expertise. I'm truly fortunate to have this entire team to work with. Now, before we close, I'd like to leave you with these key takeaways. First, that industry goals cannot be achieved by improving chemistries alone. Second, we provide a chemistry-agnostic technology to boost battery performance. Third, we validated our technology. We validated the need, had extensive external discussions, and signed MOUs with potential partners to commercialize our technology in the most capital-efficient manner. And we are now seeking $1.25 million to deliver on industry-validated technical milestones. Thank you for your time, and I invite you to join us in taking the road less traveled to make all the difference.
Great. Well, thank you so much. Several questions have come in. The first one is, where are you with SBIR, STTR grants or contracts from the DoD or NASA?
So, we will be applying for SBIR and STTR grants very soon, possibly beginning as soon as the summer of 2015. Over the last few months, we have been focusing quite heavily on business development, and we are now raising our seed round. We will be applying for federal and state grants soon.
Great. And what is your initial target market for this?
So the initial target market is the aerospace and defense market. As I mentioned, so we have chosen this beachhead market because they really need high energy density, especially for reduced weight, and they have low sensitivity to the price point. In fact, one of the letters of interest that we have is from a major supplier of batteries to the aerospace and defense industry. And we have one more MOU with another manufacturer coming up, which is also key to this industry.
Okay. And what is your valuation?
We've raised our angel investment on a convertible note, and so we'd like to raise our next investment in some form of convertible debt as well.
Okay. And what are your top milestones for the $1.25 million? What are you trying to achieve with that?
So with the $1.25 million, we'll be able to demonstrate some of the key aspects of our technology. So basically, when you start developing battery technology, data is what everybody wants to see. All these partners. So it's a highly technical field. So people will really understand us and get into partnerships with us only when they see the data. So some of this money is going to go into getting that data and validating those technical results. And converting some of these MOUs into joint development agreements thereafter. And thereafter, we will work on a concept design for a roll-to-roll prototype towards the end of those 18 months.
And what is your energy density? How is the weight versus energy density measured?
So now, since we are not working on chemistries, so the energy density boost is compared using the same chemistry. So, for example, you have a given cathode and a given anode. You compare it with thin electrodes and thick electrodes that we can make, and that regardless of chemistry is about 15%. For some chemistries, it can go as high as 20%. So we have built a pretty sophisticated estimation model to do this, and we've been able to achieve those electrode thicknesses in the lab. There's independent data from models developed by Argonne National Lab and so on. And there is a study from MIT which also confirmed that this increase in electrode thickness is valuable both in terms of performance as well as in terms of cost.
Right. Well, there are numerous previous trials on electrodes that do energy density and throughput. Have you done a competitive analysis against these technology trials?
Sure. So if we look at our competitive landscape, and as I mentioned, most of the companies trying to increase energy density are working on developing better anodes or better cathodes. So we see our partnership. We see most of these startups as a synergistic with us. There are some companies who are working on electrode designs. And our key differentiators with them is basically that we can make ultra-thick electrodes without sacrificing power density. Now, that is one key aspect that has prevented most people from accessing this advantage. There are a couple of we have found a few other companies who are trying to work on high-capacity electrodes that also give high power, but they're not as compatible with roll-to-roll manufacturing. Most of these solutions are still at research stage. Some of them use expensive processes. Here are a couple of examples, actually. There's Ballast Energy, which is a startup out of Hawaii. They make really, really thick electrodes, but they have very, very low power capability. I believe they are targeting grid storage. And so with grid storage, low cell cost is critical. So margins are obviously going to be very low. We see that as a very difficult market and with a very long adoption timeline as well. There's also a company called Preto Battery out of Colorado. And again, they're making a similar effort, but they're using very expensive processes and it's not compatible with roll-to-roll.
Well, one last question is, this seems like a very capital-intensive business. How much further capital do you think you'll need to raise to get to a cash flow break-even proposition?
So, with the seed round that we're raising now in a Series A, we expect to raise somewhere between $4 and $5 million. And but most of this, we are trying to get into these joint development agreements by Q1 2016. And we expect that a lot of this development cost is going to be paid by our partners in joint development agreements. The scenario that I gave you is a likely scenario. We have a worst case scenario and a best case scenario. The best case scenario is that a lot of our projects are funded by either partners or with grants that we will be able to get within the next 18 months. And so a lot of this funding need can be reduced and the timeline accelerated with this funding.
All right. Well, that's all the time we have for questions now. Thank you so much for your presentation.